So this is question 69. We have a ball thrown from a window 50 meters above ground with a velocity of 50 meters per second, but that velocity is at an angle of 37 degrees. So we went through at the beginning of the lesson, and what I'm going to do now is just do a simple illustration and complete the horizontal and vertical table. Okay, so here's the table completed, and let me just talk you through it. The horizontal displacement is what the question's asking. How many meters from the base of the building does the ball hit the ground? So we've labelled that horizontal displacement. Okay, that's what we need to work out in this part. The vertical displacement is minus 50. And remember, if our starting point is here, we need to basically decide this is positive and this is negative. And because it initially moves this way, we will assume that that's positive and this one's negative. It gives us minus 50 meters. I forgot to add that in. Okay, our initial velocity, if you remember, we found by resolving this situation into its horizontal and vertical components. And we did that by using trigonometry. So if I put that down here, UH, the horizontal initial velocity, would be equal to the horizontal component, which is 50 cosine 37 degrees, which is equal to 40. And our vertical situation would be the sine, so 50 sine 37 degrees, which gives us 30 meters per second. Oop, that's a 1. Okay, so that is our initial horizontal and vertical velocities. Now, final velocity. The final horizontal velocity is 40 because there's no acceleration. And our final vertical velocity, we have no idea. We do know, however, that the acceleration is 10 meters per second squared. Our time is unknown as of yet, but that is probably the first thing we need to find. Okay. Now, in order to find how many meters from the base of the building does the ball hit the ground, the most appropriate equation to use is the second one here. And in fact, this is pretty much standard for all of these oblique projectile style questions. This is the most common formula that's used. Now, if we substitute the values in, you'll find it's quite interesting because we are going to end up with a quadratic equation. So we're going to use the vertical components, okay, to find time using this equation. And that would give us S, which is minus 50 equals U 30 T plus half times minus 10 T squared. Tidy that up a little bit to make naught the subject of the equation. Okay, so now this is our final quadratic equation. Now, the quickest way to do it is to plug it in to the mathematical quadratic equation formula. Now, let me just remind you what that is. So here it is, if you can't remember it from maths. It's minus b plus or minus b squared minus 4ac over 2a. And of course, just to review, our a would be the coefficient of the square function. So this would be a, this would be b, and this would be c. Okay, so you plug those values into that formula. And don't forget, of course, that this a is minus. Okay, and you end up with two results. You should end up with either 1.35 minus, which is nonsense because you can't have minus time, or 7.35 seconds. So in this situation, where you use the quadratic equation to find t, you disregard the minus number. So it gives you 7.35. Okay, now once you have time, we can put those values in. We can write down 7.35, 7.35. And you now have enough information in the horizontal column to find horizontal displacement. And in fact, you use exactly the same formula. But this time, we don't need the second section because horizontally there's no acceleration. So acceleration is gone, this section's gone, and we're left with displacement equals initial velocity times 2. So displacement is equal to initial velocity 40 times 7.35. I said 2 instead of t before, sorry about that. And that should give us an answer of approximately 294 meters. Okay, so that's the answer to A. Let's do part B now. Now for part B, we now need to find the maximum height the ball reaches. So we need to find this point here and this vertical displacement. So we kind of need to adjust the table. So I'm going to redo the table now to consider just this part of the journey. So we're going to start in the same place as before, but this time we're going to end up here. So by now finishing at this point, how is our table different? Well, our displacements, we have no idea, okay, what the horizontal or vertical displacements are. Our initial velocities are still the same, and our final velocities are different in that now we do know what the final vertical velocity is. It should be 0 meters per second. Okay, so that number is there for us, and everything else is the same. So how do we find that maximum height? Well, the first thing we can do is to find t again. So we can find t by using the equations of motion. This time it's very straightforward. We can just use v equals u plus at using the vertical column. So we end up with 0 equals 30 minus 10t, which gives us t equals 3 seconds. Now we have 3 seconds in that column, we can easily find the displacement vertically. And we can use either of two, but if we go back to that formula, the displacement vertical, we have 30 times 3 minus, because it's half a, so I could leave it like this, half times minus 10, 3 squared. That would be equal to 90 minus 5 times 9, 45. Okay, and that gives us a distance of 45 meters. But, okay, this is a trick question because it's asking you the maximum height from the floor. If you remember, the original window, the ball was actually thrown from a height of 50 meters. So we're adding to that. So our final distance is 45 plus 50, 90 meters. Let's do the third part of this question. The last question is, what is the velocity when it hits the ground? So, remembering that it's a vector, as the ball lands like this, at an angle, which we will need to find out, it has both horizontal and vertical components. Okay, if we have a quick look at our table again, let me just add this in, vertical and horizontal. We have loads of information now, so it should be fairly straightforward. We know that the horizontal final velocity is 40. So we know that this is 40 meters, but we don't know this final velocity. But we can work it out simply using the first equation, v equals u plus at. And if we apply the values in the vertical column, we have final vertical velocity is equal to 30 minus 10 times 7.35, which will give you a value of 43.5 meters minus. Now, interestingly, we get a minus value, but remember, we originally decided that plus is going to be in this direction by putting these two values, the original velocities, as positive in the upwards direction. So now the velocity is acting in the opposite direction, down, we have a minus value attached. Okay, which is fine. It makes sense. Okay, so now we have both our horizontal and our vertical components. We now need to find the resultant velocity. So if we consider this as we would a triangle, 40, of magnitude 40 this way, and magnitude 43.5 this way, then the resultant can be found using Pythagoras. Okay, and you should get a final answer of 59 meters per second.